pretty complicated problem that's going to use the fundamental theorem of calculus. So let's take a look at it and dive in. So below is the graph of f of x on the interval -6 to 4. So what you're looking at is f of x. You always want to remind yourself, what is the graph I'm looking at? It's f of x. All right, this is my mission. Find the equation of the line that's tangent to h of x at x equals -3. H of x. All right, so let's see what h of x is defined as. Here's my h of x. H of x is the quantity x squared plus 1 times g of x. Well, what the heck is g of x? G of x is the integral from -5 to 2x of f of x with respect to x. All right, so when you're seeing a complicated problem like this, you just want to go to your question and start looking for the ingredients that you need. Find the equation of the line tangent to h of x at x equals -3. Okay, to find the equation of the line, we basically need two ingredients. We need a slope and we need a point on that line, right? So we need slope of h of x at x equals -3, and we need a point on the line. Okay? So, how are we going to go about doing this? You know, let's start by finding the point on the line. That doesn't seem too bad. I already know my x value. I know my x value is -3. Okay? So, if my x is -3, so I'm going to find a point. I know my x is -3, so basically I just want to find h of -3. And then I'll have my point, -3, whatever that y value is. Okay, so I want to find h of -3. So let's go to h. So h of -3, I'm going to be plugging in -3. So I'm just going to use this function right here. So it's going to be -3 squared plus 1 times g of -3. Okay, let's see if I'm still on the camera here. Are we still on the camera? Not really. Okay, let's zoom over in this direction. Okay, so you see what I did? I just substituted in my -3 for my x. All right, so this part is straightforward. That's just going to be a 10 times g of -3. Okay, g of -3. Well, let's go back to g. G, of course, is the integral from -5 to 2x of f of x. So to find g of -3, I'm basically going to find my integral from -5 to 2 times -3 of f of x dx. Okay, so far so good. So let's see, 2 times -3, if my calculations are correct, that will give me a -6. So I'm just going to erase this little puppy here and put in a -6. So I am now looking for the signed area between f of x and the x-axis from -5 to -6. I hope you guys are thinking, ooh, -5 to -6, I'm going backwards. -5 to -6 is going to be this slice right here. Okay, that area. And you know, I failed to tell you that that goes down to -2. So I'm finding the signed area from -5 to -6. So first of all, let's just find that signed area. That looks like a triangle to me. So it's going to be 1/2 base times the height. This distance here is 2. This distance is 1. So 1/2 base times height. That's going to be 1. Now it's -1 because the area is below the x-axis. But I'm going from -5 to -6, so that becomes a +1. So this is going to end up giving me 10 times positive 1 or 10. So my point so far is negative 3, 10. That is a point on my tangent line. Are we okay so far? So again, I'm finding the point on my tangent line at x equals negative 3. I just substituted negative 3 into my function for h of x. In order to do that, I had to find g of negative 3. G of negative 3 was the signed area between f of x and the x-axis. But since I'm going from negative 5 back to negative 6, it's going to be the opposite. If you recall, we could have rewritten this as 10 times negative 1 times the integral from negative 6 to negative 5. All right, so far so good? So we found our point. We have negative 3, 10 is our point. All right, so now let's find our slope. So I'm just going to write this over here. We have our point on the tangent line, and it's negative 3, 10. So far, so good. All right, now we want to find the slope of this tangent line. Well, slope, of course, we get from the derivative. So I want to find the derivative of h, since I'm finding this line tangent to h at negative 3. Okay, so I want to find the derivative of h at x equals negative 3. All right, derivative. So I'm going to take the derivative of h, which is that complicated thing. Let me write h of x over here. X squared plus 1 times g of x. Well, how am I going to take the derivative of h of x? Well, h of x sure looks like a product to me. Something times something. I'm going to use my good old-fashioned product rule. Here we go. So h prime of x, product rule, the derivative of the first times the second as it is, plus the first as it is, times the derivative of the second. All right, there we go. The product rule in action. Let me just move this so everybody can see what's going on. Okay, so if I want to find the derivative when x is negative 3, all right, I'm just going to, now it's safe since I took the derivative, to replace all those x's with negative 3's. Let's see, this is just going to be 10 times g prime of negative 3. All right, goodness gracious, here we go. 2 times negative 3, negative 6. G of negative 3. Well, my g function, if I scan back over to my g, is the integral from negative 5 to 2x of f of x. So g of negative 3 is going to be, oh, heck, isn't that what I already found? And of course, I erased it. So let me rewrite that again. Negative 5 to negative 6 of f of x dx. Hey, that was this little triangle here. And we decided that that was 1. That was 1. So I already found that. That's kind of nice. Plus 10 times the derivative of g at negative 3. So how am I going to find g prime? Well, g prime means I have to take the derivative of g of x. So how do I take the derivative of an integral like this? Fundamental theorem of calculus, part 2. That's right. We're taking the derivative of an integral. We know how to do that. If this is a constant and this is some expression in terms of x, I'm going to, when I take the derivative, replace the input with 2 of x, with 2x, and then multiply it by the chain rule. Right? That's my fundamental theorem of calculus, part 2. So here I go. So g, let's just not put in the 3 yet. Let's just do g prime. So the derivative of that integral is going to be f of 2x times the derivative of 2x, which is 2, right? So let's see, that's going to be negative 6 plus 10 times 2 is 20. Now let's go ahead and put in my negative 3. 2 times negative 3 is negative 6. Oh, f of negative 6. That's f of negative 6. I want to find the y value on this function. Well, the y value of f when x is negative 6 is negative 2. So I'm going to replace that with a negative 2. And I have negative 6 plus negative 40, which is negative 46. Ladies and gentlemen, that is my slope of my tangent line at x equals negative 3. Okay, I realized that you couldn't see what I was doing there, so take a look at that. So again, I did the product rule. I substituted in my negative 3. I did everything I could, but then I realized, ooh, I have to take the derivative of g. So really, I'm going to take the derivative of g with respect to x. That was my fundamental theorem of calculus part 2 with the chain rule. Then I substituted in negative 3 for the x. F of negative 6 is just the y value of f when x is negative 6, which we decided was negative 2. And that gave me my slope. So this is my slope of h of x at x equals negative 3. Wowie kazowie. So now let's put this all together, shall we? Let's put this all together and answer the question. The question, of course, was asking for the equation of the line tangent to h of x. And my answer, I'm just going to write it in point slope form because I like that the best. Y minus my y value, which is 10, equals my slope, which was negative 46, times x minus my x value, which is negative 3. And there is the answer. Of course, for those of you who are big fans of y equals mx plus b, you can just expand that out, combine like terms. But there it is. That was a monster of a problem, but very satisfying.